Alright, we are on page 140. This is section 7, topic 2. And it is called Solving Rational Equations. A rational equation contains at least one rational expression. Remember, rational means a fraction, okay? Rational is a fraction. So when we're solving rational equations, you have to have at least one fraction in the equation to be considered a rational equation. You can simplify a rational equation if you first clear the equation of denominators. You can do this by multiplying the least common denominator by the rational expressions in the equation. You can do this by multiplying the least common denominator by each expression in the equation. And another important thing to know, my little star, when solving rational equations, it is possible to get extraneous solutions. You must check all solutions in the original equation for extraneous solutions. So extraneous solutions, that means like you solved the equation and you solved it correctly, but the actual answer that you got doesn't actually work when you substitute it back into the problem. Generally, when you're talking about rational equations, you're going to get an extraneous solution, and you'll know it because if you substitute it into the denominator, it'll turn your denominator into a 0, okay? And you'll know you can't have a 0 in the denominator. So they're pretty easy to check, but you do have to check them because if they make your denominator a 0, then you can't call it a solution. So my first example, what are the solutions of the rational equation? And the equation is x divided by the quantity of x minus 3 plus x divided by the quantity of x plus 3 equals 2 divided by x squared minus 9. Okay, and up in the problem, or not in the problem, but in the what we wrote above the first problem, it said you can simplify a rational equation if you first clear the equation of denominators. So when you have fractions in any problem, in any equation really, and I believe we've done this so far this year, I've showed you how you can clear the fractions. You just multiply every single term by the least common denominator, and that will make your fractions go away. Okay, so that'll be a whole lot easier to deal with than all of these fractions. So when you have these kinds of problems, look at each of these denominators. So I have x minus 3. As a polynomial, could that be factored further? No, it's linear, right? The only way to factor a linear polynomial is if it has a greatest common factor. So one of our least common denominators will be x minus 3. How about in this second term, just at the denominator? It has a denominator of x plus 3. Can that be factored any further? No. So that's different than our other denominator. So we have to include it. How about x squared minus 9? Can that be factored further? Yeah, x plus 3 and x minus 3, right? Because it's a difference of two squares. So I'm going to rewrite this in factored form. Remember, we would make two sets of parentheses. One gets a plus, one gets a minus. The first term is the square root of the first term, so that's x. And the second term is the square root of that second term. Do I need to add another least common denominator over here, or is it already covered? It's covered. You don't want to repeat anything, okay? If you've already got one of them there, then you're good to go. We already have an x plus 3, and we already have an x minus 3. So the rest of this, nothing needed to be factored. I'm just going to bring it down. So to clear the fractions, we have to multiply every term by the least common denominator. When your term is written as a fraction, it's just one term at that point. So we've got one term here, and one term here. Alright? So I'm going to do this in a different color. I'm going to multiply every term by x minus 3 times x plus 3. And those are all in the numerator of a fraction. So y'all know how we can cross reduce, right? So like in my first term, x minus 3 and x minus 3 will cancel each other out. In my second term, x plus 3 and x plus 3 will cancel each other out. And in my third term, x minus 3 cancels x minus 3, and x plus 3 cancels x plus 3. Everybody cool with that so far? So now I'm going to go back and write what's left. So in my first term, and these are multiplying together, okay? So x plus 3 times x. Since x is a monomial, I'm going to write it first. So x times x plus 3. And then I'm adding whatever the second term is because of this plus sign. So plus, I've got x times x minus 3. Denominator canceled, just like it did in the first term. Then I've got an equal sign. On the other side of the equation, everything canceled except for the 2 in the numerator. So if we multiplied everything just say by x minus 3 and not x plus 3, well this fraction would have canceled, but this wouldn't, and only part of this one would. So you got to make sure you multiply by the least common denominator so everything in the denominator cancels and you're not left with any fractions. Now what do you think I do? Done? Let's solve for x. Distribute. So x times x is x squared. X times positive 3 is positive 3x. I'm going to go to my second one. Positive x times positive x is positive x squared. Positive x times negative 3, negative 3x equals 2. Now I've got x squared plus x squared, so I've got like terms there, positive 3x, negative 3x, all on the same side of the equation. So let me clear that up first before I move anything from one side to the other. What is x squared plus x squared? No, x squared times x squared is x to the 4th. 2x squared. Just add the coefficients. So 2x squared. What's a positive 3x minus 3x? Alright, so we don't have to worry about that. And then just equals 2. Now, do we need to subtract 2 from both sides and bring it over, or can I just solve for x like it is? I can solve for x like it is. If that linear term would not have canceled, then I would need to bring the 2 over and solve for x that way. But because I'm missing a linear term, I'm going to solve for x like it is. So at this point, I'll divide by 2. So x squared equals 1. Now what? Take the square root of x squared, and we're still going to do the positive and negative square root of the constant. What is the square root of x squared? X equals, what's the square root of 1? 1, so it'll be positive 1, and negative 1. So check your solutions in the denominator, okay? If x is positive 1, will 1 minus 3 give me 0? No. Will 1 plus 3 give me 0? Will 1 squared minus 9 give me 0? Nope. Okay. What if I substitute in negative 1? Is negative 1 minus 3 0? Negative 1 plus 3 0? Negative 1 quantity squared minus 9 0? Nope. So my solutions are fine. There are no extraneous solutions. If you want, you can substitute them in everywhere and simplify and see if it works out correct. I did that in my notes before, but it's really not necessary. You just want to make sure that they don't give you zeros in the denominator. That's what's going to make them extraneous. But when I plugged it in for the whole thing and simplified, I still got true statements. But as long as you make sure they don't give you zeros in the denominator, you'll be all right. Everybody okay with that one? Now, I remember in college algebra, what I remember most is doing this kind of stuff. What we're going to be doing in this section, I feel like in college algebra, we did that a lot. So make sure you pay attention. All right, example 2, page 141. Now, that was a long time ago, so I could be wrong.
How long ago?
Long time ago. In the 90s.
In the 90s?
Mm-hmm.
How old are you?
45.
I'm like the same age as my mom. Where'd you go to school?
I'm recording this.
Where?
Talk about it afterward. A couple places we'll talk about it afterward. Let me get through this. Okay, 6 divided by x plus 3 equals 4 divided by x minus 3. These are considered rational equations because I have at least one fraction. All right? Can either of those denominators be factored further? No. So what's my least common denominator? X plus 3 and x minus 3. I've got two terms, so I'm going to multiply both terms by x plus 3 and x minus 3. You don't want to distribute all of this out before you cancel anything, okay? So x plus 3 and x minus 3 will cross reduce or cross cancel. And on the other side, x minus 3 and x minus 3 will cross reduce or cancel. So my factors or my denominators are gone. Only thing I have left on the left side, I have 6 times open parentheses x minus 3. Put your equals in the right place. And on the right side, I have 4 times the quantity of x plus 3. So I'm going to solve for x, just distribute. 6 times x, 6x. 6 times negative 3 is negative 18. Equals 4 times x is 4x. 4 times 3 is positive 12. Is there anything I can combine on the left side or the right side? No. So I want to get my x's on one side, my constants on the other. So there's a couple things you could do to start this off. Me personally, I would choose to subtract 4x from both sides. So 6x minus 4x is 2x. Bring down the minus 18. And 4x minus 4x is 0. Bring down On the positive 12. Y'all know how to do this. Easy part. Add 18 to both sides. 2x equals 30. And x equals 15. Check and make sure it's not extraneous. In the denominator, is 15 plus 3 0? No, it's 15 minus 3 0. No. You can even check it in your head. 15 plus 3 is 18. 6/18 reduces to 1/3. Over here, 15 minus 3 is 12. 4/12 reduces to 1/3. 1/3 equals 1/3. We know for sure we're correct, right? So that one was very easy. You have a question on it? Alright, let's do example 3. We have 1 divided by the quantity of x minus 1 plus 1 divided by the quantity of x plus 1 equals 2 divided by the quantity of x squared minus 1. Can any of those denominators be factored further? The last one, right? X squared minus 1, what is that? Difference of 2 squares. So to factor it, 2 sets of parentheses. 1 gets a plus, 1 gets a minus. We had a test over this, so we all know what to do. What would be my first term in each set of parentheses? X, because it's the square root of the first term. What's the second term in each set of parentheses? 1. This is the square root of the last term. And my other terms, nothing factored, so I'll just bring those down. Least common denominator. Somebody give me one factor of my least common denominator. X minus 1. Is that it? X plus 1. Do I have any more? Nope. So now what? What was the purpose of me getting a least common denominator? Yeah, I want to multiply every term by the least common denominator because I want my fractions to cancel, right? So in my first term, x minus 1 and x minus 1 cancel. In my second term, x plus 1 and x plus 1 cancel. And on the right side of the equation, x plus 1 cancels, x minus 1 cancels. So I'll write what I have left. I should not have any denominators. So I have 1 times x plus 1, which is just x plus 1, plus 1 times x minus 1 is just going to be x minus 1. If that was a minus sign, I'd have to be careful because I would have to distribute the negative, but it's not. Equals, on the other side, everything canceled except for the 2. Is there anything I can simplify on the left side? X plus x is 2x 1 minus 1 is 0. So 2x equals 2. Divide by 2. X equals 1. It is an extraneous solution. Because if I substitute 1 right here, 1 minus 1 is 0, right? If I have 0 in the denominator, it can't work. I didn't have any other solutions. It's not like I had 2 solutions when I did this. I only had 1 solution. So the only solution we have is extraneous. We don't have any other solutions to go by. So are there any solutions to this equation? Nope. The answer is not 1 is extraneous. That's not the answer. 1's not a solution. We call it extraneous because the math worked out. We did the math right, but when we substitute it back in, it makes a false statement, okay? So since there's no other solutions that we found, like if we would have taken the square root and we got a positive, negative, or something like that, and it worked out, fine. But since that's our only option, and it doesn't work, there's not a solution to the original equation. Because the math works out correctly. This just happens sometimes in the math world. But when you substitute 1 back into the problem, for example, my first term, if I plug in a 1 for x, 1 minus 1 is 0. You can't have 0 in the denominator of a fraction. It's undefined. So that means that it doesn't work when I plug it in. It makes an undefined term. You know what I mean? So even though the math worked out correctly, it's not actually a solution. It just happens every once in a while. We call that an extraneous solution. You got to make sure it's not because we did the math incorrectly. That would just mean you got a wrong solution, right? But if you did the math correctly, but it makes a false statement, that's called extraneous. Coolio? Y'all are pumped. I can tell. You may need me to wait for example 4? We're good to go? All right. X squared minus 14 divided by 2x, I didn't mean to do this easy one, but it'll be fast, equals 5x divided by 2x. So a rational equation, because we have fractions in there, right? Do either of our fractions can they be factored? Or denominators, I mean. No. And they're both the same denominator. So that's all right. That just makes it easy. What's our least common denominator? 2x. We multiply every term by 2x. Both of them, it just cancels out, right? So that's easy. There's nothing to distribute. So on the left side, I'll just have x squared minus 14 equals 5x. Now, I have a linear term and a quadratic term and a constant. So can I just get x on one side and solve for x? No. Well, no, it's not a difference. 14 is not a perfect square. So that won't be a difference of 2 squares. But I can't just like add 14 to both sides and solve for x. I'm going to have to get this one set equal to 0. And in standard form. Because if you're missing your linear term and you just have a quadratic, you can just take the square roots of both sides. If you're missing your quadratic term, you can just solve for the variable. But when you have a quadratic term and a linear term, you're either going to have to solve by factoring or solve using the quadratic formula or solve by completing the square. Okay? So when I subtract 5x from both sides, right side, 5x minus 5x is 0. On the left side, in standard form, what would the first term be? X squared, and then minus 5x minus 14. So we have to solve. It's a quadratic. So we'll solve by factoring, comma, the quadratic formula, or completing the square. So I'm hoping I can solve it by factoring. If not, I would choose quadratic formula. If you want to just go straight to the quadratic formula instead of testing out the factoring, that's fine too, or completing the square. So I want to solve by factoring. What is my value of A? 1. What is B? Negative 5. And what is C? Negative 14. So, make my little T-chart. I need two numbers that multiply together to give me A times C, which A times C is negative 14. And I need those same two numbers to add together to give me B, which is negative 5. Alright, two different things. Negative 7 times positive 2 is negative 14. And negative 7 plus 2 is negative 5. So will negative 7 and positive 2 work? Yep. So make your parentheses. And we'll have x minus 7 in one set and x plus 2 in the other. Is it necessary to divide and slide on this one? No, because A is 1, right? But if it wasn't, don't forget that part or your answer is incorrect. Now, have I solved yet? No, I have factored, but I still have to solve. So we know to solve when it's factored, you just set each factor equal to 0. And solve for x. Check for extraneous solutions. If I plug 7 in for x, just worry about your denominator. Will 2 times 7 give me 0? No, they're both 2 times 7. What about if I substitute in negative 2? Is 2 times negative 2 0? No, it's negative 4, right? 2 minus 2 0, but that's multiplying. So, are either of these extraneous? Nope. So we're good to go. Anybody have any questions? Alright, example 5. X squared minus 20 divided by the quantity of x squared minus 7x plus 12. Sorry, I didn't realize you couldn't see it. Equals 3 divided by x minus 3 plus 5 divided by x minus 4. In the first term on the left side of the equation, do you think it might be possible to factor that quadratic trinomial? Well, it's a quadratic, so we're going to have to check, right? Otherwise, can you factor x minus 3? Nope. Can you factor x minus 4? Nope. So let's try to factor this quadratic and see if it has some factors. So we'll do that over on the side. We know that a is 1, b is equal to negative 7, and c is equal to 12. Little t-chart. We want two numbers that multiply together to get a times c, which is positive 12, that add to get b, which is negative 7. Alright, let's check it out. Negative 3 times negative 4 is positive 12. What is negative 3 plus negative 4? Negative 7. So my factors would be x minus 3 times x minus 4. Would I need to divide and slide? No. So I'm going to rewrite this. The denominator I'll put in factored form. What is my least common denominator? X minus 3 and x minus 4. So, of course, I'm going to multiply every single term by x minus 3 and x minus 4. Cancel out the common factors. And then with every term, I'm just going to go and write down what's left. So in the first one, only thing I'm left with is x squared minus 20 equals, make sure you put your equals in the right spot. And the second one, I'm left with 3 times the quantity of x minus 4. And then there's a plus sign. And my last term, I'm left with 5 times the quantity of x minus 3. So everybody cool with that? Okay, I got to solve for x. I need to get rid of these parentheses, so I can't simplify inside. I'll distribute. Y'all tell me if I make a mistake, which reminds me, for 4th period, I think I caught it from my other classes, but in section 6, topic 8, the very last page of notes that we took on the graph, I made a mistake in the direction, so it was supposed to be up, down, I think, and I did down, up, and nobody told me. So y'all's notes are completely wrong on the graph on that one. So if I make a mistake, even if I'm recording or not recording, please don't be afraid to let me know so I can fix it. So y'all have the wrong information and I don't post the wrong information. Or if you're wrong, well, we can talk about it at least. But if you think I made a mistake, please tell me. All right? Because I do sometimes make mistakes. Anybody see any mistakes I made so far? Okay. So on the right side, I can definitely combine some like terms. On the left side, I can't. But before I start moving stuff from one side to the other, let's combine like terms. So on the left side, I'm just going to bring down x squared minus 20. On the right side, what is a positive 3x plus 5x? 8x. What's a negative 12 and a negative 15? Negative 27. So I do see that I have a quadratic term and a linear term and constants. So I'm not just going to be able to get x on one side and my constants on the other and solve for x, right? Because I have a quadratic term and a linear term, I'm going to have to get everything on one side in standard form and 0 on the other. All right? So I will subtract 8x from both sides. I'm going to go ahead and add 27 while I'm at it because I'm running out of space. On the right side, I should be left with 0. On the left side, I have x squared, my quadratic term, and then my linear term is negative 8x. And I do have two constants I need to combine. Negative 20 plus 27 gives me a plus 7. How to solve for x? No, I've got a quadratic trinomial. To solve a quadratic, I can solve by factoring, sometimes, not always. I can solve using the quadratic formula, always. I can solve by completing the square, always. So I'm going to try to factor this. So if it's factorable, A is 1, B is negative 8, C is positive 7. In my little T-chart, I need two numbers that multiply together to give me AC. That's positive 7. Add to give me B, which is negative 8. You have any questions? All right, let's see. Negative 7 times negative 1 is positive 7. What's negative 7 plus negative 1? Negative 8. So that works. We have x minus 7 and x minus 1. Now, a lot of students are still telling me, if I said, what's the solutions, they would say, well, it's a minus 7 and a minus 1. Is that true? No, when you set them equal to 0 and move the constants to the other side, isn't it going to change the sign? Yeah, so my solution should be positive 7 and positive 1. If I substitute 7 into any of my denominators, well, I get a 0. If I substitute 1 into any of my denominators, well, I get it at 0. So are my solutions both good? Good to go. What's this page number? 142 that we just did?
Yeah.
Why do I what? Not mine. Student left it in here. I wish it was mine. Anybody have any questions? You're still writing? Speak now. Alright, page 143, example 6. Two more. Well, this one and another one. We have x divided by 4 minus 5 divided by x equals 2. Can anything be factored? Nope. What's my least common denominator? 4x, right? You can write it as 4x or 4 times x. It doesn't matter. It means the same thing. So I'm going to multiply every term times 4 times x, or 4x. Sometimes I write it separately because some students get confused when you're only canceling out a part and you write it as a monomial. So in my first term, my 4's cancel. You can't cancel the x's. They're both in the numerator. You can only cancel the numerator from one with the denominator from the other as long as you're multiplying them together and they're the same factors, right? In my second term, the x's cancel or reduce. Over on the right side of the equation, does anything cancel? No, my denominator is a 1. Okay, I don't have a fraction, so I'll just be doing 2 times 4 times x. Is everybody cool with that? So over here, what's x times x going to be? X squared minus 20. And I didn't put parentheses because I only had one term. Okay, if that was like x squared minus 20, I would definitely need to put parentheses because I would have to distribute the negative. But I didn't. Equals 2 times 4 times x is 8x. Am I going to be able to get x on one side, the constants on the other, and solve that way? Nope, because I've got quadratic and linear terms, so I can't do that. So I've got to get it set equal to 0 and in standard form. So I will subtract 8x from both sides. On the right side, 8x minus 8x is 0. On the left side, make sure you put it in order. Students are still writing x squared minus 20 minus 8x because it's just in order that they see it. But would that be standard form? No. Should be x squared minus 8x minus 20. It's a quadratic, which means I can solve by factoring, quadratic formula, or completing the square. I'm going to try factoring. A is 1, B is negative 8, C is negative 20. Just because all the problems that we've had so far have been able to solve by factoring, that doesn't mean on your homework that's going to be the case. Okay? We've just gotten lucky. I need two numbers that multiply together to give me A times C. A times C is negative 20. And that add to give me B, which is negative 8. What? 2 and negative 10? 2 times negative 10 is negative 20. What's 2 plus negative 10? Negative 8. It is factorable. Make your parentheses. We'll have x plus 2 in one set and x minus 10 in the other. Do I need to divide and slide? Nope, because x is 1. Any other number and we would. Have we solved yet? Nope. Set each factor equal to 0. and solve for x. So our factors or our solutions are negative 2 and positive 10. If we substitute those back into the equation, are either of them going to give us a 0 in the denominator? No, so we're good to go. One more. Four x squared minus 24x. Now in your numerators, don't factor those out until the end if we need to. In the beginning, you only want to factor the denominators. So quantity divided by 3x squared minus x minus 2 plus 3 over 3x plus 2 equals negative 4 divided by x minus 1. Can I factor x minus 1? Can I factor 3x plus 2? No, they're both linear. They don't have a GCF. 3x squared minus x minus 2, now that's a quadratic. So we might be able to factor that, right? So we need to check and see. We do that on the side. We know a is 3, b is negative 1, and c is negative 2. I need two numbers that multiply together to give me a times c. So a times c is negative 6. And add to give me b, which is negative 1. Alright? Negative 3 times positive 2 is negative 6. What's negative 3 plus 2? Negative 1. So it is factorable, right? So our factors, I'm going to do it over here. I don't want to do it over in the problem. I want to get it all finished. Are x minus 3 and x plus 2. Will I have to divide and slide on this one? Yes, I will, finally. Because a is some number other than 1. If you don't divide and slide, you're going to get solutions, but they're not going to be the right one. Is 3 divided by 3 going to be a divide or a slide? Divide, and what do I get? X minus 1. 2/3, divide or slide? Can you reduce before you slide on this one? Nope. So what's in your 3x plus 2? And once you divide and slide, your factors should be correct. Just do a little quick check. First term times first term. X times 3x should give me 3x squared. It does. Last term times last term should give me my last term, and it does. We're not solving yet. We're not solving. I haven't found my least common denominator. Okay, so all I'm trying to do is factor up here in the problem. So let me rewrite that first term with my denominator factored.
Excuse me, Mrs. Riley?
Yes?
Could you please tell me if Caitlin Listen is in class?
She is.
Okay, thank you very much.
You're welcome. So what do I do when I get to this point? Find my least common denominator. So I know I have an x minus 1 from here. And I know I've got a 3x plus 2. Remember, don't repeat anything. My second term has a 3x plus 2. We've already got one of those. Over here, we've got an x minus 1. We've already got one of those. So x minus 1 and 3x plus 2. I shouldn't have written that so close. I'm going to write them on this side since I wrote that too close to my problem. Bless you. And I'll cancel out my like factors. And then I'll write what's left. So on my first term, everything canceled but my original numerator, 4x squared minus 24x. I'm adding the next term because it's a plus, and I've got a 3, open parentheses, x minus 1, close parentheses, equals. On the other side, I've got minus 4, open parentheses, 3x plus 2. Is everybody cool with that? So now I'm going to distribute. Y'all don't need me for. On the left side, I do have some like terms. I'm going to combine those. So I have 4x squared, negative 24x, and positive 3x make negative 21x. Bring down my minus 3. I do have quadratic terms, linear terms, and constants. So I can't just put x on one side, 0 on the other. So I'm going, or a constant on the other. So I'm going to move everything over to the left and combine like terms. And I'm running out of room. So I have a quadratic that I need to solve. Either solve by factoring, solve using the quadratic formula, or by completing the square. I think it might be factorable. So I'm going to try that. We know A is 4, B is negative 9, and C is 5. Well, T-chart, I need two numbers that multiply together to give me A times C. That's a positive 20. And add to give me B, which is negative 9. Bless you. Negative 5 times negative 4 is positive 20. Negative 5 plus negative 4 is negative 9. We did it. So I have x minus 5 times x minus 4 equals 0. Am I going to need to divide and slide? Yes. by 4 5/4, divide or slide? Slide. Can I reduce 5/4? No, so what do I have in my parentheses? 4x minus 5. 4/4, divide or slide? Divide, so what do I have? X minus 1. Are these my solutions? No, they're my factors. I still have to set each factor equal to 0 and solve for x. So I got my solutions are 1 and 5/4, but I should have checked both of my solutions first before I put the little bubbly cloud around them. If I substitute 5/4 into, go up to where everything's factored. If I substitute in 5/4 anywhere, is that going to make anything a 0? No. What about if I substitute a 1 in? Yes, because 1 minus 1 is 0. 1 minus 1 is 0. If it happens even one time, it cannot be a solution. So 1 is extraneous. Do not consider it a solution. And I'm out of room. I like to write extraneous. That does not mean it's a solution. It's not at all. The only solution we have is 5/4. Everybody good? Anybody have any questions? Is that a no? While y'all are finishing up, I'll just explain real quick. On the homework, you only have 2 problems. On one of them, when it gets down to the quadratic and Dewey factor or quadratic formula, complete the square, it won't be factorable. So you will have to do the quadratic formula on one of them, just as a hint. But you only have 2 problems. You tell me that. I told you that part. You'll know when you do it because you won't be able to factor it. But I'm not telling you which one. We only have 2. So I'm going to pause the videos. Everybody finished with this? No, I'll keep talking. All right. I'll pause it. You can still see it. Or stop it. Bless you.